we're good to get going at this point. So my name is Chris Boyd. I'm a senior program manager lead on the project engineering team. I've been with the project team now for about 8.5 years. I've actually spent my entire working career on the team, so I have quite a passion for Project Server and the architecture, because my entire adult life has been every day spending every kind of working moment building this service out and building the server out. I'm joined by fellow colleagues that are also on the Project Server and Service team today. So there's Alex, who's my dev counterpart lead. So he's the guy who's actually programs and makes the actual app and writes the code. And then Nadine here in the front, who's doing the next session. Your session's on security. So security and going into all the great advancements that we've done with Project Server Security. So in the 8.5-year journey, for me, that starts around the 2007 development timeframe, coding timeframe, where we totally rebuilt the server from the ground up. And since then, we've been slowly morphing that server into a service and building it to a service that can further scale and grow to meet the demands of our users. And what I'm hoping to do today is kind of give you a flyby of the service, an introductory tour to begin with. I kind of want to put everyone on the same level field, so we're going to go start off with some basic terminology. Hopefully I won't put too much of you asleep. Just for a show of hands, who is familiar with our architecture? And how many of you are deeply familiar with our 2010 or 2007 architecture, for curiosity? Okay. I'll probably spend some time also discussing the deltas between the two and the comparison between both of them. But I'll cover basic terminologies just so we're all on the same page. In case I start to use some internal lingo, I'll give you probably 8 different ways that we call Project Client internally, so that way, as I'm talking about Project Client through the slides, I may use words like WinProj or Project Pro. And then we'll go in and we'll give you kind of the 500-foot view of the service. So we'll start with the basic building blocks, the WFE, the app tier, and the SQL tier. And then I'll go in and look deeper into each of those tiers and what happens on each of those tiers and how the tiers interact with each other. We'll also go over concepts like the project service application and how that service application fits within the context of the SharePoint farm, and then hopefully answer some questions of what is a PWA instance, what's the logical boundary of a PWA instance, and where all the data and the storage is. And then lastly, I'm hoping to close on the data movement and how data flows through the service. So I'm going to start out pretty basic. Project Web App. And a lot of people ask what Project Web App is, and many people have varying definitions of Project Web App or PWA. But from an architectural standpoint, we consider this to be the website that most of the users go to interact with project data. So this is where the project manager and the portfolio managers can navigate to Project Center and see the list of projects and understand where those projects are at. They can drill in and view the schedule. It's where the resource manager goes into Resource Center and be able to understand what their team is working on and the availability and capacity of individuals. They can quickly discover, is Joe overloaded and over capacity and his work-life balance is way out of whack, and be able to offload work to another individual. It's also where we expect team members to be able to go and report status on the tasks that has been assigned to them. Now that Project Web App, or PWA that we commonly refer to, interacts with what we call the project service application. And this is just like any other kind of SharePoint service application that resides in the farm, similar to Excel or Search. And it really is the brains of our system. And this is where all the business logic resides within the service. That project service application primarily interacts with the project database. And that's where we have our persistent storage. So we store everything in SQL databases. This is where your projects, tasks, timesheets, your resources, all that data for that one particular PWA instance gets stored. So we refer to that as our project database going forward. In addition to that, we have Project Client. This goes by many names, many names. You probably know it as Project Professional or Project Pro for Office 365. But from an engineering and architectural standpoint, all of it is the same bits. It's identical bits. It's the same thing. And internally, we typically call it WinProj. That's the executable name. But it is just the simple client. Well, I wouldn't call it a simple client. It's the great project management experience client that interacts with our service application. And then lastly, project sites or SharePoint sites that have had the working on a deadline app installed on it, which gives you that task list and the timeline in 2013, heavily interacts with that project service application in the 2013 architecture. That's not to say we didn't interact with project sites in previous releases. We did things around issues, risks, and deliverables. But in the new version, we do a lot more tighter integration with the SharePoint task list, the timeline that we showed in the keynote, and also a bunch of things around security and SharePoint security, which I'm not going to cover. Nadim's going to cover in the next session after this. Yes?
What project services application code in 2010?
So yes, that project service application resides in 2010 also.
And that name?
Yeah, no, it's called the project services application. I think we actually added an S to the name in 2013, which I can go into the long internal debate to why we added an S. But in 2010 it's called the project service application. 2010 is the services application. So just around questions, I will ask that people go to the mic just because we are recording the session and we want to make sure that we capture the session or the questions for people that watch the recording. So, done with the basic terminology, and now I'm going to kind of jump into the software requirements. And these are kind of the building blocks in which we build Project Server on top. And back in 2005, when I joined the project team, fresh out of university, I was amazed by all the functionality and features that the product provides. And I just couldn't really grasp how the project team up in Building 17 in Redmond was able to build all this functionality and features. And my PM lead at the time, Patrick Conlon, I think described it well, which is we stand on the shoulder of giants. And that's very true for Project Server. And three particular giants that we stand on is Windows Server, SQL Server, and SharePoint Server. So we continue to push the platforms and take advantage of the new features that get delivered in the platforms. So with the 2013 release, we do require Windows Server 2008 R2 SP1. We do support the Windows Server 2012, and in the very near term, once Service Pack 1 gets released, we will add support for R2 of 2012. The database version, we've also moved ahead, and that's primarily because we want to take advantage of new features and functionality within SQL Server, not just to make you buy a new version of SQL Server. But we do require SQL Server 2008 R2 SP1. So we've done things like started to re-architect our server to use things like table value functions that allow us to interact in a more performant way, in a reliable way, when saving your projects from Project Client or Project Server to the database, and removing requirements like the client-side runtime for .NET. The other giant that we build on is SharePoint. And we always call it out as a separate product, but internally we treat SharePoint as an engineering org as part of the project. Like we're all one kind of team. It spits out at the end of the day when we start to license and build subscriptions and our business folks take over. They skew it and productize it. But internally, we are just a component within SharePoint. And this allows us to build on similar infrastructure around setup and upgrade and have similar DR and topology configurations. There's also tons of advantages of us being part of that SharePoint system, in that for IT admins, they get to have a very similar working experience with the product. So, you know, installing a CU with SharePoint is the same as installing a CU in Project Server. Running upgrade, managing DR, all those type of IT administrative tasks carry over between the two worlds. And then from an end user perspective, there's great value in being SharePoint and being built on SharePoint. It allows us to do richer integration with, you know, doc collaboration and list integration and Excel services. So I think there's tons of great stuff that comes along with being part of SharePoint and building on top of SharePoint. We do have a few optional components that you can interact with in our architecture. One in particular is Exchange Server. This provides the ability for team members to report status in clients that they're familiar with, like Outlook or OA, or their phone. So if you have your Windows phone and you have your task list, you can mark it done, or some other competitive product that might be competing with Windows Phone, and reporting things done. And we've also added support for links. So as Heather demoed in the keynote yesterday, she was able to quickly pull up that contact card and have a quick conversation to get status from Eddie on where he is with his project. And this actually is a component which you can stand side by side, but our server actually architecturally doesn't ever communicate with Link Server. It's a client-side piece. One other thing, which today it seems hard to believe, but there was a point in time where our architecture didn't support all the mainstream browsers. We were very focused on IE, and we were kind of late to the game to providing support across all the main browsers in the market. And in 2010 SP1, we made some inroads here. We started opening up some of our scenarios to Firefox, Chrome, and Safari. In 2013, we have full support across the board, which is awesome for people that like to use different browsers, who I will leave nameless at this point. So, starting to think about the architecture. The first kind of step is to start thinking about the three major building blocks that make up Project Server. And these are the same kind of three building blocks that make SharePoint, because it's all one in the same product. And when we start to think about it, we have web front ends that we commonly refer to as WFEs. I had one dev that would always call them woofies, but it was just the one dev that called them woofies. Application servers or app servers, and then our database server. And you basically have these three building blocks that you can work with. Your WFE is really there to manage your user traffic. And the idea of it is that you kind of want to keep it on less load on it, around 60% load at most, so that it can constantly be handling the service requests and making sure the users are navigating and interacting with the data in a reasonable amount of time. So it's the thing that's serving up the web pages. It provides the endpoints to the clients. It's the thing that actually delivers the home page down to the IE browser. It's the thing that translates that project data set that's residing on the server down to the project client to interact with. It's what the apps and the SharePoints are interacting with in order to pull data from the system is those WFEs. The application server is kind of the workhorse. It's there for a bunch of asynchronous workloads. It's there to handle things that are very CPU and memory intensive, and to take things that come in, peaks and valleys. The great description is that Tuesday at 8 o'clock, all your program managers walk in the building and realize, oh, we had that 10 o'clock status meeting and everybody submitted status over the last couple of days. We got to update our plans. We got to get everything through the approvals and chug through and make sure all our plans are up to date before the status meeting. And that's a huge load on the system that just happens for a sliver in time. And that's where we rely on our application servers to take on that load and push that work through the system, push that work through the publishing reviews in PWA, and then off to reporting to report status on. But at the same time, we want to make sure those web front ends stay healthy so that traffic can continue to move through the system in a reliable way. Then the last tier is our our database tier. This is where we store that project database that contains all your project data, your task data, your assignments, in conjunction with the config and the content database in SharePoint. So there's various ways that you can take these building blocks and make up your farm configuration. So I'm going to go over just 4 different kind of configurations that we typically discuss. The first one is kind of our developer farm. It's also our demo farm. It's the farms that we use in Redmond ourselves because we are the only ones interacting with our personal farms when we're building the product. So ones that we're typically using here when we're demoing in a Hyper-V image. And this is where we will run that web front end, that application tier, and SQL tier all on the same box or all in the same VM. And that works well for 1 or 2 users. It's definitely not something for production, probably something you don't want in test, and probably not in your training environment. What we've typically seen in the past is this configuration where you have your web front ends and your app tiers running on the same hardware and on the same VM, and then your SQL tier. And then our guidance has always been kind of 2 to 1. Moving forward, we're actually changing this config, and that's because that config doesn't really mirror the Project Online SharePoint world, well, more in particular the SharePoint world, and Project Online now plays in that space. So we have to make sure we have the very similar scale characteristics and topology characteristics that you would expect in a SharePoint farm with all the SharePoint workloads. So we've done some work to actually change this, and our guidance going forward is this 2 to 1 to 1 ratio, where you're running the WFEs, the app tiers, and SQL tiers on separate machines. There's nothing wrong. You could, on a smaller deployment, still run that 2 to 1, but we're really starting to move to this config. And this is a config that actually mimics our online farms. So if you're not aware, the SharePoint Online and Project Online uses the identical bits that are used for the on-prem product. So we need a service that can scale to hundreds of thousands of tenants within a single farm, and thousands of PWA tenants within a single farm, and this is the kind of the config that we go with. Obviously, we expand out much further, but the basic ratio is 2 to 1 to 1. So our medium data set, so a lot of people try to ask, I get this question a lot, okay, so I'm ready to architect my server and I'm ready to plan it all out. What do I need? And I normally get very simple like statement that says, I have 700 projects, 200 tasks on average of my projects, and a resource pool of 500. How should I configure my farm? It's a very hard question to answer, and it's almost impossible for us to be able to provide an answer. So what we've leaned towards providing guidance of how to run a scale lab and a perf lab. And what we ask for you to think about is really what your data set is. So yeah, how many projects, how many resources, how many tasks? But also to think a little bit deeper. Are you going to do a lot of baselining on those projects? Are you going to have a lot of custom fields? Do you have task custom fields that roll down to the assignment level? Are they calculated? And all these things can really change the way that you actually want to configure the topology of your farm. Because if you imagine that, some project manager comes in and makes a very simple tweak to one little task, and the scheduling engine calculates on that, it can actually translate and change thousands of fields that they're not even aware that they're changing, which can have a huge impact on your farm. Now, if you have very simple project plans, that doesn't happen. So you really want to sit down and really think through the data set that you're going to be using in your farm. And then the second thing, when you're thinking about the architecture, you want to spend time thinking about what your data usage is like and your data patterns. One of the big things that we've done in this release is thought about geographical location of your users, or our users. So in the online service, we have a few data centers in the US, which means that you're most likely not in the same building as our data center. Hopefully nobody is in the same building as our data center because they're all locked down and restricted. We don't have access to our data centers. So we have had to really think through the problem of building and re-architecting our server so that it can be accessed by end users that are far away. So we always use the description of the user or the servers in Seattle and the users in Boston, and making sure that's a performant thing. But that doesn't get away from you guys when you're building out your architecture to think about geographically distributed users. You definitely want to think through scenarios, especially if you've moved to a topology where your web front end and your app tier are on the same box, around asynchronous workloads that could be happening when people are in a different region. So imagine that, the project manager that's sitting in Boston that's working his butt off at 9 a.m. to get a status report in by 10 a.m. And the guy in Seattle says, oh, it's time for me to do a cube build because I want my data analysis cubes to be updated. And all of a sudden, that app tier that's running on the WFE starts to construct those cubes, and that thing gets pegged. All of a sudden, that poor project manager in Boston, who's trying to get his work done, no longer can get his work done. Moving to a topology like this will safeguard against those kind of things. So, I kind of touched on our WAN performance. Ludo stole my slide, so please do not comment that I'm reusing Ludo's slide. He reused my slide. Though I'm going to talk to it a little bit differently. I'm actually very proud of this slide. We spent a huge amount of work last release re-architecting all the pages within PWA. So even if you're touching a page in PWA that looks functionally the same, I can tell you, underneath it all, it has changed significantly. In particular, our homepage. You can tell poor Alex here how many times I was harassing him over the last year to get our page performance on our homepage down below a second for a user that's sitting in Boston to Seattle, and all the work that had to happen. So we kind of think of things in generally two kind of terms: page load time initially, and this means that the server's all warmed up, the cache on the server is warm, the pages are compiled, the server is ready to go and hand the data over to the client. However, with PLT1, the client has never really talked to the server. It has cold caches, which means the images aren't downloaded, the JavaScript isn't downloaded, the CSS files aren't downloaded, and that initial page load time is normally very, very expensive. But we rebuilt all those pages, and we've done a bunch of work to optimize on that experience. We went in and looked at the various modern browsers and how many ports it opens up. And we went in and said, okay, we can have 8 ports for this particular browser. That means we want to make sure that all 8 ports are active when we're pushing data down to the client. That meant reorganizing all our JavaScript files and changing the size of those JavaScript files for the ultimate use in bandwidth. We also did a bunch of work around our images. So even though the save icon may look the same to you as an end user, we did a bunch of studies and changed the color palettes of all our icons to reduce the size of those images so that they get down to the client faster on PLT1. We also did a bunch of work to cluster them and technology to split them up as they come down, because it's easier to bring down one big image. So the images that you see on the page is one image. But what we do on the client side is we break the image up and then redistribute it through the page. But the page numbers that you're seeing here in perf improvements don't even factor in all the improvements in the architectural changes that I've been describing. These are actually showing you the PLT2 times. The PLT2 times represent when all that cache is warmed and all that data is there. And we did a ton of work to make sure that those JavaScript and the things that you need first to start interacting with the page and just read and get the information that you need to move on to the next step gets to the glass as soon as possible, and things that we consider under the fold or buried behind buttons comes in later. And that allows you to start interacting with the PWA pages much quicker. So, and then the last thing we did, and this kind of makes us look kind of sad for previous releases, but when we used to do performance and scale testing, we would do our perf testing using the config there, that developer farm. And on top of that, IE would be sitting on that same box. So guess what? When we did performance testing in the past, in 2007 and 2010, we had basically 0 latency and infinite bandwidth. So yeah, our pages loaded pretty damn fast. So the next torturous step is that green line. And what we did was we implemented a process where when we do any scale or performance testing, we actually have an application that runs on the network device, on the dev box, which simulates this. So we cap the bandwidth that's happening on them, and we introduce a bunch of latency. So the pain that the guy feels in Boston interacting with his Seattle server is the same pain that developer feels when he's coding. So when poor Alex is trying to get his job done and get his bugs fixed, we have poor Alex with a data server that physically is under his desk, but feels like it's across the country on him. So, and that's what's driven a lot of these page performance improvements. So, and we're very proud because by the time we actually shipped, we had the fastest page in SharePoint, which was our PWA homepage. So, very cool. So that's what kind of what I want to illustrate next. So what I did was, this is completely doctored up in PowerPoint, so full disclosure. Yes, this is PowerPoint animation. But what I did was I took our performance results from RTM, and what I did was I created this nice animation that shows how slow Project 2010 is compared to Project 2013 in that WAN scenario. So if your data center is far away, and this is PLT2. So these are the browsers already warmed up. Everything you visited it a few times, the server is warmed up. So it's an ideal case, but you have that distance. So I'll go ahead and click. And by now I have my 2013 homepage downloaded. I'm off to Project Center, Resource Center of my tasks, and the poor 2020 user just is able to see that and start working. So, and all these things carry across the 200 or so pages we have in PWA. Project Center, I could grab, did we put the Project Center? Okay, I have the data for Project Center has improved significantly also.
I'm just saying, under stipulation that it's the Project Center there, something it's going to take mine even longer because I'm still waiting for Project Center.
Right. But yes, Project Center does add some time to it, but it's still way, way quicker. And to be honest, if I really wanted to do it, I could have used the schedule web part, which was actually our slowest page, and was in some cases taking so this is an average case, we throw out the ends, but the schedule web part in some cases would just time out in our automation, so those results get thrown out. But I chose the PWA homepage because that page is consistent and used across by most users. But yes, you're right, Project Center would be a little slower, but it would be significantly faster than what it was in the previous release. So, scale, performance, it's a very, very tough topic. Like I said, there's not a really easy answer to figure out what the right configuration and architecture there is for your particular deployment to go with. Chris Elwell, so I've worked with Chris on performance and scale for the last 8.5 years, so we've been pushing and pushing hard to improve the performance of our product for a very long time, and he's the senior test lead on this, or senior tester on this work. So he's doing a session tomorrow at 12 p.m. He'll go into all the very nitty-gritty of how to go and run your own scale lab and figure out how to build out the right architecture in the right type of configuration, how to run all the tests and get into all the Visual Studio Code, and how to look at Fiddler to discover issues and all that good stuff. So if you want to really get deep into the actual perfect scale aspects, I suggest that you see his session tomorrow. So now that we've looked at the basic building blocks, we've gone over some basic terminology, the next thing I want to go into is kind of discuss what's happening actually in those tiers. So as you remember, we have the SQL tier, the app tier, and the WFE. And then we have those clients that are interacting, and they interact with the web front end. So we have the browser, so these are people navigating the PWA home page to the project site. Here I've decided to call Project Client Project Professional 2013. Of course, it could be Office or Project Pro for Office 365 or WinProj if you want the executable name. We also have PowerShell. So we've been doing a lot of work in terms of managing the server and service through PowerShell. And if you look at the number of PowerShell commands that we had in 2010 compared to what we have in 2013, you'll have noticed that it has grown significantly. Again, this is mostly driven by the fact that our service uses PowerShell. So as you interact with your tenant administration in Project Online, we don't have somebody in the background creating project. Sometimes it goes that slowly, you might feel that way. But what's happening in reality is we're executing PowerShell commands on your behalf to create and to figure out what farm your tenant resides in, where your PWA site needs to belong, and to set everything up. And that same PowerShell translates to the on-prem product. The other thing I would say, as we move forward and we think about the future of Project Server, and from an administrative point of view, we are pushing more and more of the configuration of the server to PowerShell and less to UI. You know, UI takes a lot of time and is very expensive. And that UI, realistically, isn't used very much. You don't create PWA instances every day. And we'd rather spend that time building greater UI for end user functionality and provide the PowerShell for IT administrators to interact with the service. It's probably also a best practice, right? You want people to go from a dev to a test to a production environment, and scripting the steps between those environments safeguards from a lot of human error that can occur. The other kind of two things that we talk about when interacting with our server are apps or applications. And now we think of them in kind of two different groupings. We think of them as the old school third-party apps, and these are apps that are using the PSI and the web services and WCF endpoints. And we've been saying for the last couple project conferences now, and we've documented the SDK, the web services will be disappearing. They're on their last end. I think I saw Bill walking here at some point. I don't know if Bill's still here. He's our dev manager, and he wants to get rid of those because it's something to maintain. But calling it out again, those web services are nearing their end. I see Bill. See, Bill, I pointed it out. Our web services are nearing their end. And we're really pushing people to the SharePoint app model and the CSOM object model. So all these things are interacting with our ASPX pages, our web services, WCF. Those things are what we commonly refer to our PSRA, or Project Server Interface, and then our CSOM. So project in 2013 has taken on the client-side object model, similar to what SharePoint built in the previous release. We now have it too, to build great SharePoint and project apps into the App Store, and then our OData head. So we had some great examples in the keynote, I think, where you saw Nintex and the workflow, and it being able to interact with the project CSOM. So there's some great rich applications that you can build. And also we continue to push on our OData, which is our reporting story for online, which is also available on-prem. And we're really, even though you can still interact with the reporting store on-prem, we're really starting to encourage people to start to use that OData endpoint. One, if you ever transitioned online, you can't access the database directly. And two, just when you're thinking about the architecture of your own service, there's great reasons to why we at Microsoft have not provided direct access to our DBs. There's security concerns, there's throttling, there's that poor user that makes a bit of a mistake in a SQL query and then can potentially affect all users across the system that you want to avoid. And OData helps protect against throttling. It's not just a dummy head that's taking those queries and spitting those queries back to the end user. So we really want people to move to OData. We know it's a little bit painful right now, but we're definitely making inroads. And as we said in the keynote, now you have the SSIS to help build your own data warehouse. So all these things interact with your business objects. Your business objects are where all the logic resides. If I was showing you a 2010 architectural diagram, you wouldn't see the business objects on the web front end. Those business objects actually only resided on the app tier. And that's why in the past, we would actually tell you, run the WFE and app tier on the same box. Because really, what we ended up doing is moving all user traffic to the app tier anyways. So you're paying this added tax to go through from one machine to another machine to service that request. And you don't get the benefits of an app tier that's handling that heavier workloads. With the 2013 release, we've added those business objects to the front end, and we recognize that certain work doesn't require heavy lifting from the eventing, the queue, and the PCS services that run on the app tier, and those business objects will do the validation, apply the business rules, and go down to the SQL tier and avoid the hop through the app tier completely. And this is why we're moving to that 2-1-1 or ratio for service topology, because now you can really take advantage of the fact that that web front end can service those user requests really quickly, stay in a healthy state, and then that heavier workload gets pushed off to the app tier. Now, of course, there are still activities that need to be pushed off to the app tier. We have, I think, still around 130 different activities that get processed by the queue, and that's something we want to be pushed there. If you're doing heavy scheduling and you need to schedule a plan, we want that to happen on the application tier. If you start having event handlers and execution of code, again, we want to move that off and unblock other users from doing work. So at this point, those business objects call back into the back end and call into the identical code into those business objects that reside there. And then they can make use of a set of services that we provide. So if you're familiar with 2007, 2010, you're probably very familiar with our eventing and queue. In 2010, we ended the workflow technology. And in 2013, that PCS box now appears. And that's our project calculation service. So up until this point, in 2007, 2010, we actually had two scheduling engines. We had the one that resided in Project Client, and we had the scheduling engine that resided in Project Server. And they were two different code bases. One was in C++, one was C, and one was in C#. One was developed in 1990, the client, and has been growing and maturing for 24 years. and one was started around 2005 or 2004, that time frame, and maturing for it just was never catching up. So to solve that problem, we dumped the old scheduling engine that we had in the server, and we now use a teared down version of WinProj. So now we have the identical calculation engine that's on both the client and the server. And QCS manages that work. The other thing that you'll notice when we think about our architecture is that we have to make sure that we're protecting the system from malicious code or a dev that accidentally writes an event handler that misbehaves. And more importantly, we can't allow third parties to develop or deploy event handlers into our data centers. And the way that we've solved this is that we now have technology to call out to remote event handlers. So you can host in Azure some event handler that we can call out into Azure and run. It doesn't need to be Azure, I'm just using Azure. You can host your own web service within your own data center or some other service that you prefer. And similar with Azure workflows and custom workflows, is now able to reside outside the system. At the SQL tier, you get your database. One of the the biggest difference for us when you look at SQL and at the SQL tier is that you see that we have one database per PWA instance. So in the last, in 2007 and 2010, for each PWA site, each PWA instance that you would create, we'd actually create out 4 databases. One draft, one publish, one for reporting, and then one for archive. There are some good reasons to why we did that, but then there was also some shortcomings with that. In particular, it was really hard to do point-in-time restore. It was actually damn near impossible to do point-in-time restore with that set of 4 DBs, because the data between those 4 DBs are heavily coupled, and you can't get that consistent timestamp of when something goes down. So we've decided to go back and consolidate, and during the upgrade process, we take those 4 DBs and we create you a brand new single project database. This is part of a journey, by the way. We'll continue to evolve our storage going forward, trying to make it more scalable and cheaper to run and cheaper to operate. But this is step 1 in that journey, where you have that single project database. And on-prem, we still have the data analysis cubes. So these are cubes that you can build reports off of. And then we have the familiar SharePoint databases. Content to be looking at. Thank you for calling it out. That's perfect. So the question was, the report thing's missing from the picture. And that's absolutely correct. And I glossed over an important point there. It's not really. It's called DBO. And we intentionally left it as DBO. So what we've done is we've taken those 4 databases and we've schematized the 4 databases. Schematized a single database with the 4 schemas represented as the 4 DBs in a single DB. And we schematized draft, working, and archived for the 3 other databases. But the reporting we left as DBO, very intentionally. Because if you have a query and you don't specify the schema, which is not very common to specify the schema, SQL will default to DBO. So we wanted all the reports to continue to work, so you don't need to rewrite your reports. And if you did specify the schema was DBO, so your reports continue to work. So DBO is reporting.
If we have many users of reporting, if we would benefit the reporting database would be on separate servers or using separate risks.
So, like I said in the past, there's definitely some good advantages to having the reporting database separated. You're absolutely correct. But then it also adds additional complexity and cost to operate your database server, which we felt outweighed, so we have combined it into one. However, to protect yourself from malicious queries and people hammering the system, the way to really do that properly is to actually use the OData endpoint, and to use the OData endpoint as a throttling mechanism to your reporting data. So we've intentionally, it's not, like I said, it's not just that we added the OData head and that we do the SQL queries on your behalf. There's tech in there to help mitigate against poor performing queries. But you're absolutely correct. If you take that, you run a bad query against the reporting DB and it's all sitting there with a draft and publish, you could run into a bad state.
So the checkpoint process we've had to do in prior versions is eliminated now?
Yeah, because you got 1 DB.
You got one
data.
Do the transactions then encompass all four parts of the publish process? Or do we have to be cognizant of the transactions being separate?
It's a very hard question to answer, and there's a lot of detail in there. From a DR perspective, the quick answer is you don't need to be worried about that anymore. You have one DB, and when you flip over to another DB with that PWA instance, you're in a good state. You can do a safe failover to another DB because it's one DB, and that's what SQL Server is looking at or
What
pointing
about
to.
point time back if you turn transaction logging on?
It should all work.
Hey, Chris,
Yep.
from a supportability standpoint, if my report required a custom table review, and it kept it in that single database as a DBO,
Yes.
receivers will not travel over that, will they?
So, sorry, I want to make sure I heard you correctly. Are you asking that if you put custom views in the reporting DB, what happens to those custom views? So what happens during upgrade is that we will not carry any customizations to that new database. If you choose to continue to make additional customizations with that new database, so if you stay away from our namespace like _MSP, we won't trample on them during a service pack or a CU. That being said, if you're building tools or anything on that and you plan to in the future move to Project Online, I would discourage developers from using the database as a data store. Primarily because if you do move to online, you're not going to be able to move that tool set over to the online world. But you can continue to make use of it like we have in the past.
Question. So now the DBOs in the same database with the app and publish, so the user have access to the DBO reporting database. Just you can access that.
Yeah, well, you can safeguard against a particular schema and lock down on a particular schema. Technically, you could have always queried the other databases for data, and I know some organizations do. That is still not a supported scenario. The only scenario we support is querying that DBO schema. If you need to lock it down, you can lock it down by schema. I'm just going to continue on. I have about 30 minutes left. I'm hoping to get through all the slides, so I'll probably leave further questions to the end of the presentation, just so I get through it all. So the queue, and I want to go into the queue in a little bit more detail, because on the surface, the project server queue looks the same, right? You create your PWA instance, you can go up to PWA settings, you can look at your queue jobs, you see the stack of jobs that the queue is currently processing on your behalf, and you can go on your very own way thinking, yeah, nothing's changed since 2010. I have my project server queue and I have my queue for my PWA instance. That's no longer true. We've actually made some fundamental changes to the architecture of the queue. The biggest being is that queue is no longer servicing your PWA instance. It's servicing the farm. So in the past, we would actually spawn out worker processes and you'd have queues for your own PWA instance. And that worked great in an environment where you had 5 or 10 PWA instances in a single farm. And that's something that we see in a traditional on-prem deployment. But that's very different when you start to scale up to a rolled and global service. And what we discovered is as we continue to increase the number of instances in a particular farm, the queue and the overhead of managing that queue overtook the app servers. Essentially, the queue would do a denial of service attack from within. And you didn't even need to put work on the farm. You were just quietly sitting there pinging itself to death. So in the online world, we're running thousands of instances in a single farm, and we can't have that happening. And as a result, we've done a lot of work so that queue will scale to a greater level, and that scale translates to the on-prem deployment also. So in this diagram, what you see is that I have 3 databases. So you imagine I have 3 project or PWA instances that are within this farm. And then I have my single project server queue within that farm. The user comes in and says, publish my project. And the queue's job is to take that job and unblock that user as quick as possible and persist that data quickly to the database. So if there's a failure, we have that data persisted but not ready to process it and do all the work that it needs to do a full published job. So what it does is it still takes that published data that occurs and puts it in the tenant's database. So it's still, the database is tenant protected and that queue data is protected within that tenant. But then it gets loaded up in memory to the queue, which is across all the farms, or sorry, across all the PWA instances, that single farm queue. And then it starts to process that work. Now the subtle difference is that when you go to a PWA instance, I'm not going to show you the jobs from Nadine's instance. So you and Nadine might be sharing a farm. And you go to PWA and you look at your queue jobs, and sometimes the queue stops processing work. It gets stuck. It doesn't happen very often, but occasionally it gets stuck. And it needs a little bit of help. And you go to your PWA queue page, and what you notice is that, hey, all my jobs, there's no jobs that are in process, there's no jobs that are in flight, there's no jobs that are failure. All I have is like, it looks like a 10th in a queue, but nothing's happening. What's really happening is there's another PWA instance that now has a failed job. So Nadine did something funky to his project plan. He somehow has blocked the queue. His job needs to get resolved and moved along on its way. So when you're thinking about the architecture, thinking about the server, you got to really take that mindset that queue is that queue is working on that PWA instance and translating it now to that queue is working on the farm instead. So I was going to demo stuff here. I'm going to actually skip the demo. I think I've covered off a lot of what we've changed here. I'm going to actually move on to the project calculation service and what it's all about. So as I was saying before, the architecture overview diagram, PCS, or the Project Calculation Service, is new to 2013, and its core responsibility is to schedule plans on the server. And the way that we've done this is that we've taken project client, and we've taken out all the end user goo, so the views, the VBA, all that stuff, and we're left with a thin version of project client that just knows how to do scheduling. And it's the same thing, the same identical lines of code, it's the same source code that is also in Project Professional, in Project Standard. So the scheduling, the algorithms that are used are identical. So the great thing here is that if we add a feature in one, it's automatically in the other. If we deliver a fix in one, it's automatically in the other. And we don't have to spend a bunch of time and resources keeping the two in sync and making sure that we have consistent experience. So a user comes in and they're editing their plan. They go to Project Center, they drill in on their project plan, they see SWP come up and they have their plan in detail. They start updating tasks and those requests get routed off to one of our web front ends. And because this is a heavy thing to do and a heavy operation, PCS is running on the app tier, so that gets navigated back to the app tier. PCS has a bunch of worker processes that are sitting there ready to take work, so there's warmed up versions of WinProj, and it says, okay, this one's warmed up and ready to go. Open up this project plan. It opens the project plan in the back in PCS, and it doesn't actually have WinProj, but it's a representation of the project using the same code, and that plan, the changes get applied to the plan, it reschedules and then sends that back off to the user, so the user gets to see its schedule on the schedule web part. Then the project manager comes in and makes the second change. And what happens this time, though, that project plan is still residing in that worker process on that app tier. So his request comes into a different web front end. But that web front end goes, oh, this project plan is already open. It's already open on this particular application server. It routes that traffic back to that app server and opens up the project plan, or continues to work with that project plan. So as that user session is active, there's an active mini version of WinProj or project client running on that application tier. Architecturally, there's a bit of a change here, and that is that now we have a sticky app server. So we keep on routing for that particular user and that particular project back to a particular app server during that, while that session is open. It's something to think about when you're doing upgrades. Some people take app servers out of rotation, maybe to do apply an update or an apply a fix. In past, project has had the stance you can take an app server out, apply the fix, put it back in rotation, and everything goes fine. However, in this particular scenario now, if people are editing and scheduling plans, You take that app server away from them, you've suddenly taken that cached version away from them. It's basically like coming up to their desktop and hitting reboot while they're editing a WinProject. And their changes can be lost. So it's something to think about when you're thinking about the architecture and how you plan to run your deployments.
What about memory requirements? Yeah, so for that, how is it different if you have like production issues?
So the question was around memory usage. Hard question to answer. Our memory requirements did move up. I think we now would say, I think 16 gigabytes. But the capacity documentation specifies what the minimum requirements are. In general, even without PCS, just SharePoint and project as a whole requires more memory on the app tier. But to figure out for your particular scenarios, the thing that we truly recommend is understand the data set, try to understand what the usage patterns are for your particular deployment, and run a scalability lab. Like I said previously, Chris Elwell will be doing a session tomorrow at 12. Go over how to really measure out your data set, figure out what your usage pattern is, and run a scalability lab to figure out how much memory you need for your deployment. But yes, it's a little bit more intensive to have the PCS there. Yep.
That sticky server scares me. If the server crash, or we need to upgrade.
We don't crash.
We're on track.
Well, maybe you should move to Project Online. We don't crash. I'll say it is something where we are acutely aware of. And I don't want to point out mistake, or not, I would call it a mistake. I wouldn't want to point out deficiencies. There's advantages to this also, right? And we believe the advantages clearly outweigh the disadvantages, like a crash, or like, taking it in a rotation. And we are still thinking through those problems and how to manage those issues. But I do also want to make sure you guys are aware that this is here. But in terms of perf, it provides a much better end user experience because you have that warmed up cache project running and operating. If we had to go and open that thing every single time, you would have a very, a fairly poor experience interacting with that project, and you wouldn't have that feeling of interacting with a live plan. So that outweighed the benefit of having to deal with this sticky session. That being said, we are aware of this limitation, and we are thinking about how to solve that, and hopefully in the future we will.
Well, the good thing is, I guess, if it crashes and publish time again, so I'll publish it anyway, right? So open a new session and we'll fix it anyway.
Yes.
So it's not like there's some loss and at the end, next time you edit it, was sort of.
You could have some data loss though, just because, let's say we don't expect the usage of sitting there and editing your plan for hours on end on the web isn't really a common use case. In that case, most people use the client because it's a better experience. But you could lose, like, if I was editing for 10 minutes and that box got shut off before a save, I would lose that 10 minutes of work because it's sitting on that cached box.
And it's not saving to the database, it's not making changes.
No.
Unless you publish.
Unless you're published, then you're absolutely correct. Or even just save. You don't even need to go as far as publish it. So,
Yes, that.
yeah. So workflow. So I got 20 minutes left and a few more slides to go through. So our workflow is all built on the SharePoint stack. And if you're familiar with 2007 and 2010, you'll notice that there are a couple of changes here. One is that we've made it easier to build workflows. SPD and Visio come into the mix, being able to author your workflows. But in addition to that, your workflows can get hosted up into Azure and run and operated in Azure. This is very similar to how SharePoint is doing things. It's built all on the same technology stack. And basically, if you go in and you create your custom ideation workflow for when you create a brand new project plan, to an end user, they're completely oblivious to these changes. They come in, they continue to interact with that project web app, and that engine is working behind in the background for them. Workflow is also a big topic. I know Steve in the audience has a session at some point. I'm sorry, I'm not advertising your session. I'm advertising Bia's session. But he's definitely a guru and has the Hitchhiker's Guide to Demand Management Workflows to help people out. But I'm going to pitch Bia's slide because she's part of the engineering team. And she's the senior tester for our workflow stuff on the engineering team. So she's doing a deep, deep dive into project server workflows and infrastructure tomorrow at 12. So we have two great competing sessions. You have the perf and scale one and the workflow one. And hopefully, I think both of them will be excellent presentations. Thankfully, they're recorded. So if you want to go to both, you'll have to pick and choose and go to the recording. So the other big kind of service and component that runs on our application server is our eventing service. And this is where, as a developer, you can build your own hooks to recognize changes that are occurring within the system. So the example I'm using here is updating a resource. So, your last name changes. You get married, you have a new last name, someone goes in and they edit that resource and updates the last name to the new one. You might want to capture that change and sync it up to a different system, some CRM system or something else. And you can do that with events. So you can register with the eventing service and say, hey, when this change occurs within the system, I want to be notified and then execute this piece of code. Previously, in 2010, you had to take that event handler that you authored and you had to deploy it to each and every application server, and you had to deploy that DLL to the application server. Unfortunately, we don't trust you in our data centers to deploy the code, so we had to find a different solution. And I would even recommend for on-prem to do this because it keeps your application server in a lot cleaner state. In that you can actually use now what we call remote event handlers. So we have a parity in terms of what events are offered in the way of deploying it on-prem or on the box, but instead what you can say is when this event happens, like update resource, instead of calling this DLL on my box, call out to this web service, and then you can do your validation, call into other systems, or choose to cancel the event. And it's just a web service, so I have Azure here in the slide as an example, but you can set up your own web server within your own data center and then have the app server call out to your web service hosted on your own box. So that's a big change from this release, this ability to call into remote event handlers. So I think I covered a lot of this in our architecture diagram. So we have the web service WCF endpoints. These are our on-premise extensibility endpoints. There's 22 of them. They follow the CRUD. They have big, heavy data sets that they pass around. So you do a read operation, you get this big, fat data set back. You operate on that ADO.NET data set, and then you give it back to the server. And it's an aging programming paradigm, and it is slowly going extinct. Just want to make sure people catch on to that. And what we've moved forward with is our project client-side object model. And this is the new SharePoint app model for building apps. And we've taken a lot of what is offered in the traditional web service and WCF endpoints and offered that functionality in the project client-side object model. To add to it, we always bring up that we do have the OData endpoint. We always talk about it in the context of a reporting story, but it's also a great developer story. You can easily go and retrieve data and interact and read that data and do things with that data as a developer.
So PSI is gone?
PSI is not gone. What I want to make sure people hear is the PSI is going away. And this is a message that we've been fairly consistent with over the last couple of years. It's documented in the SDK. So it continues to work today. It works in 2013 on-prem. However, if you're out and you're building new applications or updating applications, now is the time to move away from the PSI and move to the project client-side object model. So the days are numbered on the PSI. The other way to put it. So developer stuff. I'd say you could learn it all in a session, but I don't even think you can learn it all in a session. I think we could do a session every slot of the conference on building on top of Project Server. However, Bill Avery, who's a senior dev on the dev team and who is responsible for the client-side project client-side object model and remote event handlers, is doing a session with Chris tomorrow at 9 a.m., so this one doesn't conflict, all around building and extending Project Online and Project Server. So databases, we did chat about databases already, and we already dug some of the topics out. But from 2010 to 2013, we've taken those 4 databases, we've consolidated it into one. Like I mentioned before, we did schematize them. So basically, when you go in, if you open up the database in SQL Management Studio, you will now see that there are 4 schemas: the draft, the publish, reporting, which is named DBO for backwards compatibility and archive. And truthfully, we've actually added a 5th schema, which is called Diag. That 5th schema, which isn't shown here, is a schema which is basically a set of views back onto those 4 schemas. And if you're wondering what Diag is for, it is the way that we can troubleshoot stuff in the online service. If you look at it, it's all PII scrub data. It shows the structure of the data, but doesn't actually show it. So I can understand things like these projects and tasks are related to each other and they should be in the assignments and we can troubleshoot issues, but we're not able to see things like project names, start dates, and task names, and all the actual data that actually means something. So on-prem, if you have an organization that really wants to keep their data secure, but wants the IT organization to dig in and troubleshoot issues, you guys can take advantage of that 5th schema, the Diag schema, that provides you an insight to the structure of the data, but not actually at the data, and be able to grasp anything meaningful from that data. Also, if you have a support engineer or outside consultant that you want to help troubleshoot a system, but not see your actual enterprise data, that's another way to protect it. I think we covered a lot of the details, however, in the architecture around that database consolidation work. And Nadine has a session. Is it this one now? Sure, tomorrow. Tomorrow he has a session which will describe the whole upgrade process and the steps required to get to this state. So the next thing I want to cover is better together and how we fit into the context of SharePoint. In the 2010 world, when you wanted to add project to your SharePoint farm, from an IT experience, we were very tightly integrated. From an end user perspective and interacting with the existing data, we were very separate. We were maybe the same solar system but different planets. And what would happen is you'd create your project service app, and then you go into that service app, and you'd say, create me a PWA instance. And that would perform a huge set of steps that were tightly coupled. And what it would do is it would create a brand new SharePoint site collection. It would create a project database for that site collection, and then it would create an SP web and apply the PWA template to it. So it would do all these steps in one big operation. And what it would do is it would create a whole new place where you can start collaborating and working on stuff. And the data that you already had in your SharePoint farm and data that was happening already in task list and all that were left in a different site collection that you really couldn't easily interact with. So you basically got net new, but on the same hardware. You administrated it all at the same time, but end users couldn't really interact with the data that was already residing in their site collections. So we did a bunch of work in 2013 to kind of break down those walls. And what we did was that you'd still create your project service application, but we would make it more additive. And this is where you'll start to see a differentiation between what you can do in the UI and what you can do in PowerShell. So this is something you can only do in PowerShell. So for example, when I go to the next step, I can just create a project database. It wouldn't do much. It would just hang off the service application, and I could create 10 databases. And for most organizations, that's just silly business, creating 10 databases. Now, if you are a host or a project server, and creating 10 databases and having them pre-created, there might be some advantages there. And then you can go ahead and wire that project service up to an existing site collection. And what this enables you to do as an end user is now start having that data that resides in those sites, those task lists, to start flowing through that project service application and be part of your EPM data and start to report on it. And that's what we call, from an end user, SharePoint task list projects, PWA. And then I can go ahead and I can create my PWA site if I so choose. And that no longer has to be that root web in the site. I can create it where I feel it naturally fits in the context of my site collection. I didn't even need to create my PWA site. Let's say all I wanted to do is take advantage of timesheets. I may not want to be ready to take on the PWA site and where to put it. What I can do is just grab that timesheet web part and add it to an existing page within that site collection that my users are already familiar to going to. That being said, we don't block you from the old way of doing it. You can use central admin, go through the UI, create the Project DB site collection and PWA site, just like you did in the last release. But we give you this additional capability to add it on. So I have 8 minutes, and hopefully I can cover data flow and how data flow works within our architecture. So I'm going to keep, though conceptually, our draft, well, implementation, reality, draft, publish, reporting, and archive are all one database. For now, I'm just going to treat them as 4 different databases in this diagram just because they are still 4 separate schemas, and we treat them essentially as 4 different stores internally within that database, as like the application treats it. And I just kind of want to walk through how that translates from an end user perspective. So a PM goes ahead and creates and saves their project to project server. What that does is create that project plan within the draft and working store. And the idea is that they can go in and iterate and play with that project plan within that draft store. Once they're ready to share it with the rest of the world, that's when they go in and hit publish. And what that happens at the data layer is that that project a job gets put on the queue, on the application tier, and that job gets published or copied to the published database or the published schema. And at that point, that data now becomes available in Project Center, so all the roll-ups get updated in Project Center. My tasks and team members start to see their tasks appear in Project Center. Availability and capacity changes in Resource Center for those resources because it's now been shared with the world. At the same time, once that publish operation happens, additional jobs go on the queue to update the reporting store. So after publish has been updated, we then go ahead and take that project, denormalize it into our reporting database, and now you can report on it and pull that data from the OData endpoint and start using Excel or SQL reporting services or what other kind of BI tools you use to report on the data. The other big data flow, and we haven't touched too much on the content of the SharePoint DB stuff, but we actually do move data now between the publish schema through the content and into the draft store. And this is the interactions that you see with the task sites primarily. So now with task lists and the site and being able to keep that task list up to date with what's happening in Project Server means that we're moving data through the content database store. And then we have the 4th schema within our stuff, which is the archive. This provides the ability to have a set of projects, or you have your projects backed up, so you can have the 7 last copies of your project, backup of your enterprise pool, backup of all your views, and if something gets changed and you want to go back in time, you can use the archive functionality to then push it back into the draft and publish store. And then lastly, when we think about data movement that's happening in the system, we have data movement that actually goes from the publish and draft. And this is not a scenario that we talk about a lot, but it is a reality. And that's the scenario where a team member reports their status, they hit submit, and when the project manager approves, that's the only time we push data from the publish store and apply it back to the draft database. So that's a very high level of the whole project server. I've reached the end. If there's questions, appreciate to use the mic.
So in 2030, the PM doesn't have to do the publish anymore?
In 2013, no, the PM still needs to perform that operation of hitting publish. There's a scenario there that we want to fulfill, which is the user has that playground and that draft working store, and they're iterating on that plan, and they're not ready to share it with the world. Right? Like, I build out my first project plan, I want to get all the tasks figured out. I don't want people to start working on those tasks. It's only when I hit, sorry?
When the publish, when the data flow.
When I hit publish, that data then goes from the draft working store to the publish store. And that's when it's shared with the rest of the world. That's when you start to see the Project Center and in my tasks and in the timesheets. I can then continue iterating on that, like phase 2 of the project. Yep.
So archive to draft, you don't have the particle line, right?
That is correct. There
You
is.
guys do it in the background, so let's say over supporting and then you want to store one project.
Uh,
Support people could do it.
So no, we haven't provided that functionality, and that's primarily, there's some work that we would need to do to make sure it would scale at the online level. So currently, we don't have the archive functionality available. Oh, maybe the mic's not working, so.
What I've often wondered is where the portfolio, pre-project stuff fits into this scenario.
Into the data flow scenario, in two places. It actually resides partly in the content store, so the business drivers are stored in SharePoint lists. But also, when you start the ideation, you create the project plan, and you start to work through the PDPs, there actually is a project plan that gets created in the draft store. And as you navigate between the PDP pages, we do something called a partial publish. It isn't a full publish of the plan, so we don't move the entire plan from the draft store to the working store. We actually take a very subset of that data that you need for demand management and move it into the publish
So
store.
the EPTs that are associated with new project fit that description?
Yes.
Okay.
Yeah. Sure.
The queue, so you said it's one queue per farm now, right?
Yep.
But you still have threads per PWA instance in that queue, right?
No, so
Threads.
that's the difference. So there's multiple threads.
Yeah.
What was the question?
Oh, sorry. The question was around the queue and the number of threads around the queue and how it gets processed, I believe.
Yeah.
And you can configure the number of worker threads. And I believe the default is 4 threads when you create a PWA instance in 2010. Now, when you create the project service application, the queue gets instantiated, and 4 worker threads are created for that queue to service all PWA instances. So if you notice, we've actually taken the queue settings away from PWA settings page in 2013, and they've been moved into central administration. And in central administration, you configure the number of working threads. The number of working threads is the number of threads for the entire farm.
So in central administration, you still have the drop down for PWA side there, though.
So I can flip over. I should have done my demo. This is exactly what I was going to show in my demo.
No, I was just wondering, like,
But-
in practice, like, if you, for instance, use a profile sim, which can use, like, a lot of pre-processing power, that's gonna, like, stop other PWA instances from working for half hour, because the queue is just processing.
The jobs could be backed up behind that work. But you're right, if you go into central admin and you go into the general project settings, there's that drop down. But what you're looking at are the queue jobs across the farm. To actually administer the number of worker processes, you actually go to the managed service application, and there's a button there that says manage the queue. And then that's where the settings apply, so it's just one setting. But there is a piece in central admin that allows you to look at the jobs across the instances, and that's per instance. But the queue settings is in the managed service application. All right, 49 seconds left. Any other questions, or we can end early?
I guess,
Yeah.
I want to ask about different deployment policy. Are they scalable?
Is our topology scalable? I would say with a high degree of confidence, yes. So the online service is a single, like we have a very small set of SharePoint farms that are multi-tenanted, and we can run, thousands of instances within a single farm.
And then you want to add more servers later on.
That's why you want to do the scale out. Yes. So when I was showing you the medium and the small, what's important to take away there is that in our general guidance, though you'd want to do your own scalability lab that Elwell will describe tomorrow, but the general guidance is to have it ooh, I'm beeping. This is quite fancy. Arms are going up. The general rule is 2 to 1 to 1. So if you're going to add more capacity to your farm, you'd add 2 more web front ends, an app server, and then a SQL server to spread the load. So. Cool. So thank you very much.